Welcome to this introduction about the occasional load on piping system. My name is Miguel San Martin. I am a president for Spain of Society of Piping Engineers and Designers, non-profit organization. My currently job position is a chief stress engineer, and I have also experience as a civil engineer. In this presentation, we are talking about the different loads like snow, like earthquake, like wind, and additionally other specific case for fluid transit. This type of load will affect to our piping system. First of all, we can check the main loads on piping system. Please pay attention in this slide. Okay, in this slide we can see the three group of loads, type of loads on piping system according main standards. The first one is sustained loads, means weight and internal pressure. Okay. The second group of loads is thermal, is due to the temperature of the pipe and the expansion. And the third group, and this is the scope of work of this presentation, is occasional. In this group, you can see wind, sun, seismic due to earthquake, and a special case for internal fluid transit. Yes, in this slide, the most common load is the sustain. The sustain due to the weight of the pipe, the weight of the insulation, other elements in line with the pipe like valves. The pressure is very important to define the system for sustain case, internal pressure. Okay. Also, pressure is very important to the first step for define the flange according to the temperature and the internal pressure. This is a first step. The second group is thermal loads, expansion and the force due to the expansion of the pipe for internal temperature. The change of the temperature means. And now we are talking about the occasional loads. Okay. Yes, in the slide, it's not a pipe, it's a bridge. It's the one of the famous case of the fail of the bridge in engineering, the Tacoma. But it's very interesting this presentation to see the dynamic load due to the wind. The frequency of the system is influenced for these dynamic loads. And in our case, we can define a support to avoid similar situation to this. Other occasional load is snow and ice. Okay, snow and ice means extra weight in our piping system. Okay, and this is required for our analysis, taking account this extra weight. Usually this extra weight count for the civil codes. The maximum snow in our area geographic, national codes. And other case, also for an occasional, is due to the quake, seismic loads. Sure, you know, the segment at the movement of the ground can form the different weight due to the movement of the tectonical plates. Okay, these tectonical plates, the movement of these tectonical plates create several different ways on the ground. Okay, main ways for this system, principal way, so the compression and expansion of the ground as a longitudinal movement, and the other one is secondary wave, is like in transversional direction, vale? Like a shared. There are a lot of more ways, but we are focused only in these two because to understand the problems in our system. Okay, then sure, you know that our piping is round on building on the ground, and the effect of in a building is the effect on our piping. The primary wave, okay, is, remember, is expansion and compression of the system. The damage is usually little. And the other one, secondary wave, is shocking in transversal direction. Try to move the building of the system in lateral direction. Then usually the damage are bigger than primary wave. And the consequence in our piping system of this shocking moving, this lateral loads is considered in our system for the seismic, is cracking, okay, especially when the pipe support or our equipment were not considering the effect of the seismic in the same phase. In the piping point of view, it's very important to try the design of the pipe support for taking account this occasional load, this horizontal load. For the reason, it's common to put, for example, a bracing like this one. This is also very interesting for the wind, the bracing, because seismic and wind, on the point of view of static equivalent, is a horizontal load. For the reason is the support are very similar. Other type of support to take into account this horizontal load is the strut, is a rigid bar, U-bolt, take the force for this red pipe, and other more strong support works like a guide with a structural steel. Also, this interesting slide, this interesting picture is the simulation of the movement of the ground, and in order to see the effects in piping system. Okay, simulation of the shaking of the ground, and the different effects in pipe ground for different buildings. Okay. And this is the other one. The other one. This is a model, a simplified model in university to take the possible effects in piping system for the shaking of the ground. And this consideration, fifth consideration after big earthquakes, are reflected in standard analysis and in standard international codes. And then there is other occasional load due to the fluid internal internal fluid transient. To define this typology is not easy. We can divide on 4 different groups. The effect of fluid transient is noise, violent movements, deformation, and leakage. The first group is monophasic fluid. The variation of the velocity means variation of the pressures means an unbalanced force on the systems. And again, violent movements, leakage. The second group is biphasic fluid. Okay, liquid plus steam. This type of flow, this type of fluid transit is unstable. There are bubbles, and the problem is when the bubbles collapse. The third group is again biphasic fluid. In these cases, liquid plus gas. We can define several regimens for this type of flow. Okay, we will see on other slides. And finally, again monophasic. Yes, 2 monophasic type of flows and 2 biphasic type of flows. And the case for the loss for monophasic system, the more famous is the discharge of the release valve. First group, first fluid transit effect. What the hammer? In Spanish, golpe de ariete. The water hammer is due to a suddenly change on the velocity of the flow, usually for the closed valve. In this slide, you can see a very simple example to understand the water hammer. Is with 1 vessel, 1 pipe, and 1 valve. Simple. The valve is also in line with the pipe. And the flow, the valve is open. Okay, and in one moment, the valve is closed suddenly. What happened? There is a wave in opposite direction to the flow with a pressure and a different pressure. Okay, around in the opposite direction, in the direction of the vessel. Okay, and in one moment, all of the pipe is with the internal pressure plus this increment the pressure for the effect of the wave. If the vessel is not large enough, there is other wave, yes, in the opposite direction of the previous wave, okay, round to the bulb. Black color means bulb closed. In order to understand the water hammer, okay, we can see the most simplified analysis in order to order this pressure. Okay, and this increase of pressure, okay, is proportionally to the fluid density, the unit of the speed at the flow, and the change in the flow velocity. Please fix it. Fluid density is normalmente fixed because it's the fluid in our system. The sonic speed is proportional to the specific fluid, also is fixed. And the first step we can try to minimize the water hammer is control this change in flow velocity. How? But if the bulb is suddenly closed, the change in velocity is higher in comparison if the bulb close with more time. And now we will see the effect of the water hammer in one water pipeline supplied. Okay, we can find this movie on internet in the YouTube. It's not only an important thing for the safety, sure, for the safety point of view, is the problem when the water hammer appears. There's also a problem for the supply for the crash of the pipe. Okay, again the same movie. Okay. Other type of flow patterns, in this case biphasic. The first one is water hammer is monophasic fluid, and this one is gas plus liquid. When we find gas plus liquid in our system, there are 4 different type of patterns. Bubble, okay, the bubble of the gas inside the flow. Second one, when the bubble merges in one big bubble, the name is slug. The second one is when the velocity increase, then the slug is reducing, is take other shape, and the other one, when the velocity of the gas is higher, there is a separate round between the liquid and the gas. The gas round in the middle of the pipe, and the liquid round close to the valve of the pipe, like a separate fluid. Please, thinking about what is the more critical pattern for our piping system. Yes. Let's go. The most critical pattern for our piping system is slug flow. Why? Because when slug find one element is in the change the element change the direction of the flow, like a T, like a elbow, okay, in the system appear an unbalanced force to unbalanced force and means vibration in the system to shock this slug, sorry, with elbow. Okay, in this case also is kinetic energy, the formulation. Kinetic energy is taking into account the velocity of the slug, taking into account the area because of the mass, and taking into account the density of the fluid. Other kinds of biphasic fluid, but in this case is steam plus liquid. One of the famous cases of this type of flow regimens is cavitation. Cavitation is a physical phenomenon. Some liquids change in one moment to steam, and after this return to liquid. Also a simple sketch to understand when happened this situation. Okay, there is a pipe. Inside of the pipe there is one element with less diameter, means reduction, means bulb, and the Venturi effects change the property of the system, change the velocity, change the pressure, decrease the pressure, increase the velocities. Means with different conditions, the system change the liquid to steam and appear bubbles. After several meters or something like this, the system return to permanent pressure, the permanent conditions, and the bubble try to return to liquid, sometimes with explosion, with blast. Okay, this is my previous explication. Okay, and when the bubble blast close to the wall, the pipe wall, there is a crack in the pipe. The name of this typical crack is pitting. But the worst situation that the bubble collapse inside the pipe is the bubble collapse inside of the pumps, for example, the mechanical parts. We can see a movie. And please pay attention to the sound of the bubble collapse inside of the rotor of the pump. The noise is completely different to the normal operation. This, Other type of biphasic fluid, steam plus liquid, is when in the same system you have steam and liquid, that is with different temperature. First problem is when there is a suddenly subcolic of the steam and the steam return to the liquid, but with collapse like the previous one, but very suddenly there's a shocking in the system and balance force. And also, one of the problems for this type of system is when the condensate remain in one section of the pipe, and the steam take this liquid and push in direction of the flow. This liquid works like a slug, the previous one we saw in the previous slide, and also this is a unbalance force, a shaking, a vibration on the system. In this slide, we can see a sudden condensation and the shock. One of the famous cases of a steam hammer is the steam hammer in New York City. New York City has a very large system, very large distribution for the residential heater of steam. And what happened in the steam hammer? And now we will see a steam hammer, but in a small industrial plant. Also, this one is a problem of the safety points of view. This is very important in order to design the piping system in a proper way to minimize the condensate remains in the steam system. Take out all of the condensate in steam piping. This is interesting slide. Okay. We can see two different systems. Okay. One is steam distribution lines, and the other one is to take the condensate in this, the condensate in the steam distribution system, remove the condensate in this distribution system to avoid the steam hammer, is the condensate recovery lines. But in any case, also with these two systems, we could at different points where water hammer, steam water hammer, could be appear. And finally, we return to monophasic fluid. Is the effector relief valve, which is the proposal of relief valve. There is one system, main system, to avoid overpressure in this main system. We supplied a relief valve. The relief valve only works when the main system is on overpressure. And the advantage of this valve is remove enough flow in the main system in order to decrease the pressure in this main system. When the overpressure is in the main system, this spring inside of the relief valve move up, open the valve, and there is a fast movement in the valve, fast liberation of the fluid to decrease the pressure of the main system. This, when there is some elements like a bands, like a teeth on this system, elements which change the direction of this flow in the system, we will have an unbalanced force. Okay. And this unbalanced force means vibration, fatigue, and it requires taking account the side of the source, the side of the force, to design our system. Like a summary is sustained and thermal rod expansion shall be included in order to validate the normal operation in piping system. But additionally, according piping standards, taking in account occasional loads. Designed to avoid critical fade and safety problems.